So let us come back. Okay, now let us see the next. Okay, in client server networks. Now let us see the next topic, that fourth topic in the client server network. So what is the fourth topic? Issues in client server network. Now let us see what are the issues in client server network. Now we have basically, if you see the study material, we have two issues in client server network. Okay. Now what is the first issue? First issue is nothing but, now let us say, what is the first issue? First issue is nothing but, again, let us say you have a server and you have certain clients. Okay. So what happens if multiple requests comes at the same time? Now let us say like 10,000 requests, okay, is coming at the same time. Okay. Now what happens? Okay, the server will always maintain a queue. Okay, what do you mean by queue? Queue is nothing but the request will be maintained, or the request will be standing in a line. Okay, like request 1, request 2, request 3, request 4. Okay, like that. Okay, you will be having 10,000 requests. Now what happens if 10,000 requests comes at the same time? The server cannot process the 10,000 requests at the same time. So what happens? It takes certain time for the purpose of processing that particular request. That is the first issue. Okay. So what is the first issue? If multiple requests comes at the same time or simultaneously, what happens? The server will take its time for the purpose of completion of a task. Okay. That is the reason. For example, like if your results are announced, okay, so all the students will try to see the result. Okay. So what happens if multiple requests comes at the same time to the ICA server? Sometimes it says loading, loading, loading. What do you mean by loading? Because the server is busy, it takes certain time for the processing of this particular request. So that is the first issue. So what is the first issue? First issue is nothing but if multiple requests comes at the same time, it takes certain time for the purpose of processing the data. For example, okay, now let us say we have 3 requests. Okay, so let us assume first request will take 3 minutes, second request will take 2 minutes, third request will take 5 minutes. Okay. So first request, how much processing time it will take? 3 minutes. That means second request has to wait for how much time? 3 minutes it has to wait. Now let us say first request is completed, second request started. Okay. So second request, how much time it will take? It will take 2 minutes. Okay. So third request, how much time it has to wait? 3 plus 2. Okay, 5 minutes it has to wait. Okay, so if you see the first request, what is the first request? What is the first issue? First issue is nothing but if multiple requests comes at the same time. Okay, what happens? The server will take certain time for processing of the data. Okay, that is the first one. So what is the second issue? Second issue is simple issue. Like let us say we studied data integrity in the previous video. Okay, so what do you mean by data integrity? Data integrity is nothing but always the data will be maintained at a central location. Okay, now what happens? Let us say the server is crashed. The server is crashed, or it is also called as goes down. Okay, what do you mean by goes down? Goes down is nothing but server is not working. Okay, now when the server is not working, whether the clients can access the data? Whether the clients can access the data? No, the clients cannot access the data. Okay, so that is the second issue. What is the second issue? If the server goes down or crashes, whether the clients can access the data? No, the clients cannot access the data. So this is about, okay, these are the two issues which we have in client server network. What is the first issue? First issue is nothing but, okay, if multiple requests come simultaneously, the server will take certain time for processing of data. This is the first issue. What is the second issue? Second issue is nothing but if the server goes down or crashes, whether the client can access the data? No, the client cannot access the data. So these are two issues in client server network. So with this, we have completed the concept of, okay, we are done with, okay, we are done with function based classification. So in function based classification, we have 4 topics. First one is definition of client server network, we are done. Second one is working of client server network, we are done with that particular thing. Third one is characteristics of client server network. So we are done with characteristics. How many characteristics we have, sir? We have 5 characteristics. First one is service, second one is shared resources, third one is mix and match, fourth one is data integrity, and last one is scalability. And fourth topic which we are done is issues in client server network. How many issues we have? We have two issues. First one, if the server goes down, we cannot access the data. Or second one, if multiple requests comes at the same time, server will take certain time for processing of data. So these are two issues in client server network. So with this, we have completed the concept of we are done with the concept of client server network. Now let us go to the next topic, that is called as peer-to-peer network. Okay. So let us see what is peer-to-peer network. So second classification in function based classification is peer-to-peer network. So what do you mean by peer-to-peer network? Okay, peer means equals. What do you mean by peer? Peer means equal. So if you remember, we studied the definition of client server network. What is the definition of client server network? The client server network is nothing but server is nothing but a powerful computer and client is a less powerful computer. So if you see what is a client server network? Client server network is nothing but if a powerful computer is connected to a less powerful computer, it is called as a client server network. So what is the difference between a client server network and peer-to-peer network? So if you see peer-to-peer network, in peer-to-peer network, all the computers will be treated equally. Okay, peer means equally. Okay, so how do we connect these particular equal computers together? Okay, so we require a small device called as hub. Okay, so what is the device we require in peer-to-peer networks? In peer-to-peer networks, we require a device called as hub. Okay, hub is a device which connects all the equal computers together. For example, like let us say I want to connect four computers. Let us say this is computer 1. I want to connect the computer 2. I want to connect a computer 3 and I want to connect computer 4. Okay, so what exactly I'm doing? I am connecting four equal computers together. Okay, so this type of network is called as a peer-to-peer network. So what do you mean by peer-to-peer network? It's a simple concept. Okay, in this particular network, all the computers will be treated equally. Okay, now let us say this is client 1, client 2, client 3, client 4. Now let us say client 1 wants certain data from client 4. Okay. So who is requesting the data? Client 1 is requesting the data. Who is providing the data? Who is responding to that particular data? Okay. The response is given by the client 4. Now who is treated as client and who is treated as server here in this particular context? Client 1 will be treated as client, whereas client this C4 will be treated as server. Okay, so if you see this particular transaction, client 1 is requesting, that is the reason it is called as client. Okay, C4 is responding, that is the reason it is called as server. Now if you reverse it, okay, now let us say if client 4 needs certain data from client 1, okay, who is requesting the data in this particular scenario? Okay, the request is made by client 4 or C4. Okay, the response is given by C1. Okay, now who is requesting? Client 4 is requesting, that is the reason it is called as a client, or C4 is called as client, whereas C1 is called as a server. Okay, so it depends who is requesting the data and who is responding to that particular data. Okay, so this is about peer-to-peer network. Now, whether I can connect a numerous number of computers in this particular peer-to-peer network? No. Okay, I can connect only the maximum of 12 computers. Okay, I can connect maximum how many computers? 1 dozen computers or 12 computers. And where I can use this particular peer-to-peer networks? These peer-to-peer networks are used in small departments. Okay, small office departments. Okay, where I have office departments. In that particular office departments, I can use this particular peer-to-peer network. What's the maximum number of computers I can connect? I can connect around 12 computers. Okay, so this is about peer-to-peer network, and please remember this particular two examples. Okay, we have two examples. First one is called as Napster. Second one is called as Freenet. Okay, sometimes they may ask you. Okay, they can give you an MCQ saying that find out which is an example for peer-to-peer network 1, 2, 3, 4. Okay, one of the option will be Napster. or okay, one option will be Napster, one option will be Freenet, okay, third option will be another, fourth one will be both A and B, okay. So here in this particular context, peer-to-peer network means both A and B, okay. What is A and B? A means Napster, B means Freenet, okay. So what are the examples of this particular peer-to-peer network? Napster and Freenet, okay. So with this we are done with, okay, we are done with function based classification, okay. So we are studying classification of telecommunication networks. We are done with area based classification. We are done with function based classification, okay. In function based classification we completed client server network and we completed peer to peer network, okay. Now let us move to, okay, another classification, that is ownership based classification, okay. Let us see what is ownership based classification.